the second derivative and what it tells us about a function, okay? So the second derivative and concavity and the second derivative test. What was the first derivative test? Okay, if a function changes from increasing to decreasing at a value, then that value, it's the x value of its maximum, right? Okay, so that was the first derivative test. And then similarly, if your derivative changed from negative to positive at a point, then at that x value you would have a minimum, okay? So let's talk about the second derivative for a minute. Okay, so information from the second derivative. So let's sketch y equals x cubed and y prime on the same axis. Okay, y equals x cubed is just your what? Just the cubic function, right? And what's y prime? Yeah, y prime is 3x squared, right? So it's going to be parabolic, right? Okay, something like that. Okay, talk to me about what y prime is doing from here to here. Good. So y prime is decreasing, right? What's y prime doing from here to here? Good. So y prime here is increasing, right? And so it's like all of the slopes are what? They're all what kind of values? They're all positive, right? But these are like more positive to less positive, right? Remember we drew this once before. So if y prime is decreasing, what does that tell me about the original curve?
The slope is getting, the value of the slope is getting less and less.
Okay, yeah, so it's getting less and less. And so what does that make the curve do?
Concave down.
Concave down, right? Okay, and there's a hint right here in the title of the lesson, right? Concavity. So if my slope is decreasing, then my original curve will be concave down, right? If my slope is increasing, my curve will be concave up, right? Well, what's another way to say y prime is decreasing? If y prime is decreasing, y double prime is negative. Good, Justin. If y prime is decreasing, y double prime is negative. If y prime is increasing, y double prime is positive. Okay? So in other words, if your second derivative is negative, what do you know about the curve? It's concave down. If the second derivative is positive, what do you know about the curve? It's concave up. Okay? So that's our connection that we're trying to make here. Okay, so let's summarize that. If y prime is increasing, y double prime is what? It's greater than 0, which means y is concave up. Similarly, if y prime is what? Decreasing. I know that y double prime is less than 0, which means y is concave down. And we've alluded to this over the last couple of days. What is that point right there called? That is called a point of inflection. And what happens on a curve at the point of inflection? Concavity changes. Excellent. Concavity changes. Yeah, so now it's like the critical points occur when the second derivative is either 0 or undefined. Okay? So point of inflection. And we'll abbreviate that POI from this point on, is a point where concavity changes i.e. y double prime changes from positive to negative or vice versa, right? That makes sense to everybody? Okay. All right, so let's do an example here. Discuss the concavity and find the point of inflection for f of x equals x to the 4th minus 4x cubed plus 1. Discuss the concavity and find the point of inflection for that function. Okay, well, as soon as you're asked to discuss the concavity, what is it that should go off in your brain that you need to find? The second derivative. I need the second derivative, right? So let's find the first one. And what is it? Okay. And then find the second one. How about 12x squared minus 24x, right? Okay, so if I need the concavity, if I'm looking for the points where concavity changes from positive to negative, what do I need to find out first? Right, I need to know where it might be either 0 or undefined, right? Just like before. So we'll set this equal to 0. And what can I factor out? 12x, and that leaves me with x minus 2. So x can either equal 0 or 2. Yes, and we're going to create another sign chart, just like we did before. So I got 0, and I got 2. Now, if I want to talk about concavity, right, this little sign chart I'm making is going to be about concavity. Where do I need to test my values? In the second derivative, right? I don't want to test in the first derivative. That's going to tell me increasing, decreasing. These values might not even be right. I don't want to put it in the original, because if I put it in the original, that's going to give me y values of potential points of inflection, correct? So I'm going to test this in the second derivative. Okay, so this one right here. So let's test a value like -1. If I plug in a -1 right here, this value is negative. This value is negative. And a negative times a negative is a positive. So two positives make a happy face, right? And I should say, yeah. Don't confuse these. I'm not trying to make these are not the signs on this. Okay, I'm just making it happy. Okay, it's positive. It's positive. It's happy. It's concave up.
So you're just I get it.
Yeah, I'm not like these signs right here are not. They don't go with that. Okay. If I test a number like 1, this number is positive. This number is negative. Negatives are sad faces. Concave down.
So cute.
I know. And a number bigger than 3?
2.
Positive, and a positive times a positive is a positive, right? And positives are happy. Okay, so where is this concave up? Negative infinity to 0 and 2 to infinity, correct? Where is it concave down? 0 to 2. Where are points of inflection? 0 and f of 0, right?
2
And you understand, right, that we would need to plug 0 back into the original equation, right? Because this is information on the original graph. So what is f of 0? 1. And where is another point of inflection? 2, f of 2. How do I know that those are points of inflection? Because concavity changed. Okay? Concavity must change in order for it to be a point of inflection. So that's going to be 2 to the 4th is 16 minus 32 is negative 16 plus 1 is negative 15. Okay, so there's one other thing I want to talk to you about before you go. We had a first derivative test for determining mins and maxes, right? There is a second derivative test for determining mins and maxes. So this is a second derivative test for determining mins and maxes. Let f be a function such that f prime at c is equal to 0. Okay, so f prime at c is 0. What do you know that means?
That's a critical value.
It's a critical value, and it has a horizontal tangent, right? Has a horizontal tangent. If it has a horizontal tangent, it is either what? A min or a max, right? If it has a horizontal tangent, then that value is either a min or a max. What will be true if it is a max? The curve will be concave down, right? What will be true if C is a min? It will be concave up there. So in other words, if it's a max, the second derivative there will be negative. If it's a min, it will be Positive, okay? So here's what we got. If f double prime at C is greater than 0, then f has a what?
Maximum, minimum, critical value. Wait,
You can tell me specifically, no ifs, ands, or buts. There has to be a minimum there, right? Then f has a min at C, f of C. Right? So if you think about that, like if C has, if this is 0, but the value there is positive, the second derivative there is positive, it'd be concave up, so that's a min. If f double prime of C is less than 0, then f has a what?
Max.
A max. At C, f of C. Okay, so look at this example with me. These show up on the AP exam, okay? And they'll show up, you'll see once we start reviewing how they show up. Well, you'll see before that. If f prime of 1 equals 0, and f double prime at 1 equals negative 5. Okay, so think about that. We're at the value 1, x equals 1. The first derivative there is 0. But the second derivative there is negative. What do you know you have to have at 1? You have to have a max. Then f of 1 is a max. Does that make sense to you? If f of 1 is 0, that means you got if f prime of 1 is 0, then you know you have a horizontal tangent there. And then if the value of the second derivative at 1 is negative, then we know the curve is concave down there, so we'd have to have a max. I can see if I can work this last example with you real fast. Got 2 minutes, I think. Use the second derivative test to determine mins, maxes of f of x equals negative x cubed plus 3x plus 5. Okay, so you may be asking yourself, well, why would I use the second derivative test to do it if I can use the first derivative test, and that's easy for me, okay? That's fine, but for some people, they really like the second derivative test, and you can see it here. So what's the first thing I need to find? I need to find the first derivative, and where the first derivative is equal to 0. So the first derivative is negative 3x squared plus 3. I'm going to factor out a negative 3. And that's going to leave me x squared minus 1. So I'm going to get x is equal to plus or minus 1, right? Let me just show you this real fast. Okay? What's the second derivative of x? Negative 6x, right? These are values where it has a horizontal tangent, right? Okay? Plug in negative 1. What do you get? Positive 6. So what do you have at negative 1? A min. At x equals negative 1. Yes, it is much faster. And 1 is negative 6. That means it's concave down there. So you'd have a max at x equals 1. And I'm sorry, I know I went through that quickly. I can talk more about it. I have a worksheet for your homework.
Are we gonna finish? Do we need this second?
Just hang on to it for right now. We may pull it back up for review. Same thing with this. There's 2 sides to this worksheet. If you would just do side 1 for me, please, 1 through 8. And just hang on to the back for now. And sorry to keep you late.
We do all of these on 1 through 8?
Just 1 through 8.